In this class, I'm going to go over how to evaluate and solve radical equations. So if you could just label your paper evaluating and solving radicals. So example 1, evaluate. So it says evaluate f of x equals the square root of x plus 3 for f of 6. So notice the 6 is in the x spot. So I should be substituting 6 in for x. So what we'll do is we'll rewrite this as f of x equals the square root of x plus 3. And then now I'm just going to substitute in 6 for x. So this will say f of 6 equals the square root of 6 plus 3. And then from here, you're just simplifying the radical. So this would be f of 6 equals 6 plus 3 is 9, the square root of 9. Well, we know the square root of 9 is 3. So my answer here is f of 6 equals 3. So example 2, evaluate. So it's the same idea as the first one. So we have g of x equals the square root of x plus 1. And we want to plug in, this time, -2 in for our x. So I want to substitute -2 in for x. So I'm going to start by writing the function g of x equals the square root of x plus 1. And then I'm substituting -2 in for x. So I'm going to say, instead of writing x, I'm going to write -2. And that equals the square root of -2 plus 1. So from here, we're just going to simplify. So this is going to say g of -2 equals -2 plus 1 is -1. So the square root of -1. Well, remember, we can't take the square root of a negative number. So this is, we could say it's a non-real answer because we can't take the square root of a negative number. Example 3. So same concept is evaluate h of x equals the square root of 2x plus 24 for h of -2. So again, here we have the -2 is in the x spot. So I'm substituting -2 in for x. So I'm going to say h of x equals the square root of 2x plus 24. Then I'm going to substitute -2 in. So h of -2 equals the square root of 2 times -2 plus 24. So then just simplify. So h of -2 equals the square root of 2 times -2 is -4 plus 24. And now we're just going to simplify what's underneath the radicals. So h of -2, -4 plus 24 is the square root of 20. So we're going to use what we know about radicals to reduce the 20. So we could split up 20 using 4 and 5. So this would get me h of -2 equals the square root of 4 times 5. So h of -2 is 2 root 5. So this would be my answer there, 2 square root of 5. So the next few problems will be solving. And whenever we solve radicals, you always have to check your solutions because it is possible that you can get a solution that does not work. And we call that solutions that don't work, we call those extraneous solutions. So if we plug it back into the original equation that we were given and we get a false statement, that is an extraneous solution, meaning it doesn't work. So here's example 1. In order to get rid of the square root, so I have the square root of x minus 5 equals 6. In order to get rid of the square root, we square both sides of the equation. So squaring undoes the square root. Those cancel out. Those are inverse operations. So squaring undoes the square root. So now This would get me x minus 5. And then don't forget, what you do to one side, you do to the other. So since we squared the left side, we also had to square the right side. So this would be 6 squared, which is 36. And now this is just an easy equation that you know how to solve. So to solve this, remember, draw your line. X minus 5 equals 36. Just add 5 to both sides. So this gives me x equals 41. And now I'm going to check. So remember, you got to check your solutions, because you could get a case where one of your solutions is extraneous. So let's take the square root of x minus 5 equals 6, and I'm going to plug in 41 for x. So this will be the square root of 41 minus 5 equals 6. So this is the square root of 36 equals 6, and so 6 equals 6, so that checks. So my answer here, 41, is the answer for this problem. So it would be okay to type 41 into MathXL here because my answer checked. So example 2 will be done the same way that we did example 1. So I have the square root on one side and a number on the other. So I have the square root of x plus 8 equals 6. So again, to get rid of the square root, you're going to square both sides of the equation. Remember, what you do to one side, you have to do to the other. So the square root and the square cancel each other off. Those are inverse operations. So that gets rid of the square root. So that I get x plus 8 equals 36. And now from here, you're just solving this relatively simple equation that you're going to solve. So you're going to draw your line. Then to get x by itself, you're going to subtract 8 from both sides of the equation. And so here you're going to get x equals 28. Now, check your answer. So you need to check by plugging it back in by substituting 28 in for x. So this would be square root of x plus 8 equals 6. And I just want to check that this is true. So I'm just going to plug in 28 for x. So 28 plus 8 equals 6. So 28 plus 8 is 36. So the square root of 36 equals 6. So 6 equals 6. So again, this one checks. So it would be okay in MathXL to go ahead and put 28 in for your solution here. Example 3. So now notice we have a number with our square root. So we have 3 plus the square root of 2x. So here's the square root. So to solve this, we need to get the square root by itself. If you look at, take another look at examples 1 and 2, the square root was already by itself, so we didn't need to do anything. We were able to square both sides right away. Here, what we need to do to get the square root by itself is we need to get rid of the 3 that's outside the square root. So first, what we'll do is we'll draw the line and we'll subtract 3. So those 3's cancel. So I get square root of 2x equals 4. So very important, when you have the square root and there's something on the outside of the square root, you need to remove that thing. So we need to remove the 3. Now, this looks similar to what we did in examples 1 and 2. Square both sides, the square root and the square cancel off, so I get 2x equals 4 squared is 16. And then divide both sides by 2. So x is 8. And again, you need to check by plugging this in. So 3 plus the square root of 2x equals 7. So I'm just going to substitute 8 in for x. So this will be 3 plus the square root of 2 times 8 equals 7. So 3 plus the square root of 16 equals 7. Square root of 16 is 4, so 3 plus 4 equals 7. So this is true, 7 equals 7. So that is a true statement. So for MathXL, this would be okay. You could plug in 8. Example 4. So here's my square root, is right there. So I have the square root of 5x plus 1 minus 6 equals 0. So again, I have to get the square root by itself before I solve it. So I can add 6 to both sides of the equation. Here's my line. So those 6's would cancel. So I would get the square root of 5x plus 1 equals 6. And then square both sides so that the square and the square root cancel. So I get 5x plus 1 equals 36. Then I'm going to leave you to go ahead and finish that one up. Make sure you check at the very end, check your answer. So you're going to have to plug in whatever value you get for x. Example 5. So 2 times the square root of 5x equals 10. So here, notice I have a 2 on the outside of the square root. So here's my square root. And now the outside I have a 2. So first I need to get rid of that 2. So I'm multiplying my square root by 2. So to undo the multiplication by 2, I'm going to divide both sides by 2. So those 2's cancel. So I have the square root of 5x equals 5. And then to get, now the square root is all by itself. So to get rid of the square root symbol, you square both sides of the equation because the square root and the square cancel off. So I get 5x equals 25. Divide both sides by 5. So you get x equals 5. And again, we're going to want to check that this answer is true. So you're going to do a check. So I'm going to leave you to check it. So you're going to plug in 5 for x. So you should get a true statement here. So the last set of examples, the last 2 examples we're going to see is what happens when you have a square root on both sides. For example 6, we have square root of 2x minus 7 equals the square root of 3x minus 12. So there's a square root on both sides. There's no other numbers or anything like that on the outside. So what we can do is we can just go ahead and square both sides of the equation. Because remember, squaring undoes the square root. Squaring undoes the square root. So it's going to take everything that was underneath the square root, and you're just going to take it out. So this is going to be 2x minus 7 equals 3x minus 12. Whoops. And then we'll just solve that for x. So we'll subtract 2x from both sides. So here's my line. So those cancel. So I get negative 7 equals x minus 12. Then add 12 to both sides of the equation. So you get x equals 5 for your answer there. And again, here you would check just to make sure that your equation is true. So if we check this, so I'm just going to show it. So here's my check. So the square root of 2x minus 7, is that equal to the square root of 3x minus 12? So when you plug in, this will be square root of 2 times 5 minus 7 equals the square root of 3 times 5 minus 12. So this is 10 minus 7 equals 15 minus 12. So 10 minus 7 is 3, so this is square root of 3 equals 15 minus 12 is 3, so square root of 3 equals square root of 3, so this is true, so this checks. So your answer here would be 5. 7 will be done the same way. So we have the square root of 3x minus 4 equals the square root of 2x plus 9. Start off by squaring both sides to get rid of the square roots. And so all those cancel off. So now I get 3x minus 4 equals 2x plus 9. And then I'll just leave you to go ahead and solve that for x. Make sure at the end you check your answer. And just so you know that you did it right, this should work. This should be true. So this does it for solving. There is an assignment in MathXL called Solving Radicals that you can do.